Okay, this video is designed just to be a quick overview of the Pythagorean Theorem, and I think that we've all seen it before. It's a squared plus b squared equals c squared, where c squared is the longest side in a right triangle. Remember, it has to be a right triangle, okay? And some of the key concepts that we want to remember is that any time that we go ahead and we have a square root of a number and we square it, it's just going to be the number that is under the radical sign. So for example, if I had the square root of 5 and I raise that to the second power, that would just give me 5, and that works every single time. Another thing that we need to go ahead and do is be able to simplify radicals. Okay, so for example, the square root of 45, we break that down into 9 and 5 and 3 and 3 from the 9. So basically we're doing a factor tree. We take out any sets of doubles and we make them into 1, and everything that is left on over, like that 5 there, stays under the radical sign. Okay, so here's what we do. Some examples of the Pythagorean Theorem. So what you want to do is sometimes just go through and just label the sides there. So there's C, and then it doesn't really matter which you call A and B. A is usually the smaller side, and B is a little bit is in between A and C, but it doesn't really matter is for A and B. C is the only one that matters, which is going to be the hypotenuse, which is always across from the right angle. So I put these on in. A is just going to be x, so I got x squared plus 4 squared equals 5 squared. So I start to do out my arithmetic and algebra from here. That's going to give me 16, 25. I'm going to subtract 16 from each side, and that is going to give me x squared equals 9. And then I take the square root of each side, and that is going to give me x equals 3. So I know that x is 3 in that particular example. So sometimes the numbers come out real nicely. In this next example, they might not be so nice. And it looks like we got some similar numbers, but they're in different places. And so let's see how these play out. So A is going to be 3 squared plus 5 squared equals c squared. So now we end up with 9 plus 25 equals c squared. 9 plus 25 is 34 equals c squared. Now we take the square root of both sides, okay, and we end up with c is this. C is going to be the square root of 34. Now what we want to do is check to see can I break that down any, and it looks like I can't, because it's the two factors are just going to be 17 and 2, and we can't do anything with those from there on out. So we're just going to leave it as c equals the square root of 34. Okay, so knocking out this next one. All right, and this is where if we have a side that's already a square root, this is where this guy right here, that concept, is going to come into play. Okay, so let's knock this thing out. I'm going to go A, B, and C and plug this in. So I end up with x squared plus the square root of 26 squared equals 7 squared. So I start to break this down. X squared plus 26 equals 49. I want to subtract 26 from each side, and that's going to give me x squared equals, those go out, and I end up with what, 23. And from there I take the square root of both sides, and that is going to give me x equals the square root of 23. Okay, and then finally I did want to include one that had a number outside the square root, because oftentimes that goofs up students when they plug it into the Pythagorean Theorem. So I'm going to show you how to tackle that. It is, let's go A, B, and C. Plugging this on in, we get 2 squared plus x squared equals 5 square root of 2 squared. Okay, so 2 squared is going to be 4 plus x squared equals, so now with this guy right here, we're going to square both of these. So that means is that I'm going to do the work up here. 5 squared is going to be 25, okay? And the square root of 2 squared is going to give me 2. So I would have 25 times 2, which is going to give me 50, all right? So subtract 4 from each side, and that is going to give me the square root, not square root, x squared equals 46, okay? And then I'm going to attempt to take the square root of that, and let's see what happens. We got to break this down to see if I can. So I'm going to go, let's see, 23 and 2. I know that 23 is prime, so it looks like we're stuck with the square root of 46, okay? So that is how you navigate the Pythagorean Theorem, and I want you guys to try the examples below and check them on the PDF that follows. So, see you in the next video.